Over the past 2 decades, tennis has been rapidly evolving, not just in how it's played, but in how it's analyzed. From high-speed cameras to real-time analytics, technology is now an essential part of the sport. Hawkeye is a vision application used in many sports with many capabilities like tennis ball tracking, which is used in professional matches to make line calls and provide player insights. But those systems are expensive, rely on specialized hardware, and are mostly limited to high-level play. For our final project, we wanted to see if we could replicate some of that functionality using just video footage and modern computer vision techniques. We were motivated by a shared interest in how machine learning can be applied in sports technology, and we want to show that this system can be used not only in professional matches, but also in local coaching, player training, or even recreational games. So, how does it work? In our implementation, we use YOLO, or You Only Look Once. It's a deep learning-based object detection algorithm that can identify and locate objects in an image or video pretty fast. We use the Ultralytics library, and you can see that you can just pass in an image and it'll return the bounding boxes of certain objects. For videos, it runs the YOLO frame by frame. However, you can see here that it is not perfect. When we ran it on a tennis video, it couldn't track the tennis ball at all. To improve performance, we trained a YOLO model ourselves using a tennis ball dataset from RoboFlow, which included labeled images of tennis balls. After training for a few hours, we got a pretty decent model. Aside from the poor quality videos, you can see here that our model can track the ball better than the pre-trained model. Here are some other examples. We then headed to the tennis courts at Epley to get footage of ourselves playing tennis and test out our model. Well, we have to get good footage first. On our third try, we finally set up the camera correctly. Here are our results. As you can tell, the model is not performing that well, likely because the camera angle is not the same as the ones used in the training data, which was based on professional match footage. Because of this, we also observed that our model couldn't track the balls well when they are on the farther side of the court, possibly due to the noisy background rather than a solid ground color. We also experimented with the side angle, and the results were surprisingly not too bad. We then messed around and tried multiple balls. You can see that it really only detects decently well for the closer person. Through this project, we explored how modern object detection models like YOLO can be applied to track a tennis ball using only video. While our results had limitations, the project gave us valuable experience in training vision models and understanding the challenges of object tracking. In the future, we could improve performance with better data or explore other advanced tracking techniques. Overall, this was a great opportunity to apply what we've learned in computer vision to a real-world task.